Hey guys, it's Dylan. We're back here. So today I'm going to be doing something crazy. I'm going to be debunking the physics behind Beyblade. Why am I doing this? I don't know. But in the end, listen, it's overall a great show. If you haven't watched it, you should probably watch it because you know what? It's my childhood, so watch it. Yeah. Anyway, now on to the actual stuff. Okay, so we're now going to be systematically looking at each component of the Beyblade series and why it's just not physically possible. So we're going to be focusing on two different occurrences. The first of which is going to be when the famously known Kiyoya's Beyblade, Rock Leone, basically created 3 tornadoes within a 10-foot proximity of each other, just basically instantaneously. Why does this not work? Because that's a lot of energy. It just is. No matter how you look at it, it's just not possible. The second occurrence is going to be when Yu's Beyblade, Libra, essentially made a stadium made out of concrete turn into sand. Yeah, sand. That takes a lot of work. That takes millions of years for normal rocks to simply just turn into sand. So imagine how much force that takes. So that's what we're going to be looking at today. Okay, so what I did in this scenario was I looked at tornadoes and stuff. So this is going to be Kiyoya's Beyblade. And initially I found the average tornado speeds, and a lot of websites were saying 60 miles per hour. So I quickly converted that into meters per hour, and then from meters per hour to meters per second because of velocity. And then as you'll see that I'm about to do, I then begin to convert the weight of the Beyblade into kilograms and find the revolutions per second. The reason why I'm doing this is so that I can deal with the circumference, as you'll see in a second, by finding the radius of the Beyblade. And now what I begin to do is I begin to find the total distance and velocity of the Beyblade, so I can begin to start my my force equation, which I actually am doing right now. Perfect. So as you can see, I got 17.53 newtons for my answer as for the Beyblade, like how much it just does per second. So that's a big difference, 7.82 times difference between the Beyblade and the Tornado. So I quickly calculated how many newtons it would be if the Beyblade were, or the Tornado were the size of the Beyblade. And that's a lot compared to our mere less than 20 newtons for the Beyblade. So, and then I calculated it into joules for later calculations. You'll see it's procedure time. So the way I'm going to do this is going to be slightly different. So we're going to be figuring out the sand part, because, listen, it's just wrong, flat out. There's just no way this can be right. So the way that I'm going to approach this is I'm going to do it while I'm doing the actual math, because it's just a lot, and I have to look into jackhammers and how those work and stuff. So as you can see, I just wrote high. So first what we're going to do is we're going to deal with the single impact energy, which essentially covers every time the jackhammer goes up or down. That is essentially what each impact is. So we quickly converted that to joules, otherwise Newton meters. So now what we did is we multiplied by every single impact per minute. That's the I over M. I doesn't stand for impact, I just pretended it did. So we got those overall joules, and then we divided that by 60 seconds in order to get it to watts. The reason why is because watts is the number of joules per second. That is important because that's what we'll compare to later. Okay, so now is when stuff gets pretty weird. Gotta change my thought. So I converted from ounces to grams to kilograms. You'll see why later. And that's for the weight that we see in the Amazon description. So we then found the radius through the packaging, as mentioned before, and then we found the circumference of the Beyblade. And then using this, we then, I believe, go to the revolutions per, the revolutions over 10 seconds to find the revolutions per second. So the distance and velocity are what we found next, and they are going to be the same because it's per second. So it's already on that second basis for velocity, and I'm keeping the distance on a second by second basis. So now we're doing our centripetal force equation because it goes in a circle. So but so that ended up equaling 10.63 newtons, and then we multiply that by the total distance in order to find the work in joules, which then ends up being 34.65 joules, otherwise known as 34.65 watts. We can do this because it's already on that 1 second basis. So 34.65 divided by that is itself. So now we see the final part. I give up. Why is it 24.6 times higher than that Beyblade? That just can't happen. And we have to consider at the same time that this is only to turn rocks into smaller rocks. We're not considering the fact that he's turning it into sand instantaneously. So yeah, like it's not even a completely accurate number, yet it's so already astronomically larger that it's just wrong. It's just wrong no matter how you look at it. So yeah. Okay guys, it's conclusion time. So you know what, I decided for my conclusion, because I already proved that this is just messed up, I'm just gonna, make a thing that's representing how absolutely absurd this is. So I'm just gonna leave this image for you. Look at the difference between all of these. Yes, the jackhammer probably shouldn't be that large and I probably did something wrong, but still, look how astronomically different this is from one another. This is crazy. Anyways, bye.